To review from yesterday, because this is essentially a part 2 lesson from what we did before, you guys need to know the definition of a function, and I don't ask you to memorize much in this class, but this is one of them. You need to be able to write this verbatim, and the definition of a function is first that it is a type of relation. So you need to know what the word relation means, because I could always ask for that word as well. A relation is just any set of ordered pairs. It can be expanded to be beyond ordered pairs, but for our purposes, we're just going to call it any set of ordered pairs. It's a type of relation in which each element of the domain, now I don't want you to say each domain. An element is a term in set theory that means a part of or a piece of. So each part of the domain, which we described element, is transformed into, we think of a function as a transformation. It changes one number into another number. Is transformed into one and only one. That's important as well. That means an if and only if type statement. One and only one element of the range. So get that down, use Quizlet or whatever you need to memorize that, but by tomorrow we're expecting that 100% memorized, and we're not kidding about that. So let's start with this kind of word here, domain, because what we're kind of thinking about with domain is a lot of things. But one of the big things, one of the big things with domain is that we have rules of the domain. Rule number 1 of domain. And there are many, but we're just going to do 2 of them. Rule number 1 of domain is that there can be no negative under the radical in real numbers. And we're going to be working within real numbers here. We're not going to expand that until much later. So that's rule number 1. There's no negative underneath a radical. So what that looks like is if I have let's say that I have a function f of x is equal to the square root of x minus 1. That means that x minus 1 has to be greater than or equal to 0, which would then mean that x has to be greater than or equal to 1. That would be my domain, because anything not that would give me a negative underneath the radical. So rule number 1 is that no negative underneath the radical in real numbers. Another way of saying this is that the radicand, which means the thing underneath the radical, is non-negative, which means greater than or equal to 0. So that idea is going to come back much later. Rule 2 is one you also know, and in a way this is actually the primary rule in math, but I'm just calling them different things. No 0 in the denominator as a factor. That's the old you cannot divide by 0 rule. So we're going to practice this in a series of problems. First thing, the directions are going to be to state the domain. So state the domain, and you've got g of x equals x squared plus 1. I'm really getting annoyed at that thing. Okay, g of x is equal to x squared plus 1. Well, when I say state the domain, I mean tell me what possible values the domain can be, and in a sense, what possible values can it not be. Is there, hang on, anything that can't be squared and then added to 1 and plus 1? I can't think of anything. I can't think of anything we can't square and then add 1 to. So my domain for this one is just all real numbers. Now, range is a different question. When I look at range for this, and if I say state the domain and the range, it thinks that I want to, okay, I get it. Okay, I'm sorry, I'm just realizing why this thing's coming up. Sorry, I just updated to a new version of Windows, and it's messing with my wanting to bring the keyboard up whenever I touch the bottom. I do not. Okay, domains, real numbers, range. So I'm going to pause this and see if I can fix that for a second. Okay. Anyway, back to this. The range means when I plug in values for x, what happens to y? So if I look at x squared plus 1, the smallest that x squared could ever be is 0. And so when I look at the range, the smallest that x squared plus 1 can be is 0. Or sorry, is 1. Because the smallest that x squared can be is 1. Or 0, so the smallest that x squared plus 1 can be is 1. Smallest is another way of saying y has to be greater than or equal to 1. So that gives me the range. I'm going to put that in set notation so it looks like a better range. Okay. Now, let's look at another one. This is driving me nuts. I might have to pause this and try to figure this out again. Looks like I have to suffer through it. Okay. Part B, I have the ordered pair 1, 0, -1, 0, 2, 4, so when I have that and I ask for the domain, I'm just asking you to literally list all the possible x values. So that would be -1, 1, and 2. All the possible x values. And the range is just listing all the possible y values. So that's going to be 0, 4, 0, and 4. And no, we don't repeat range values. Even though there's 2 zeros that are present, I just list it once. Okay. Letter C. I'll give you a function. H of x is equal to 7 over x plus 7 times x minus 7. Now, we just said the denominators cannot be equal to 0, and the two values that would give me a 0 in the denominator, well, mathematically, I can say that x plus 7 times x minus 2 cannot be 0, and solve that equation, actually that inequality, say that x cannot be -7 or x cannot be 2. And that is the domain for this. It'd be all x such that x is not equal to -7 or x is not equal to 2. Range for this one would be a separate issue and kind of a separate class. We're going to leave range out on that one. Let me do the domain for one more. Phi of x is equal to the square root of 2x plus 1. Now, we just kind of saw this up above. I know that 2x plus 1 has to be greater than or equal to 0, which means that x has to be greater than or equal to -1/2. So that would be my domain, all x such that x is greater than or equal to 1/2. My range, though, is a little bit trickier. And if I look at range, I have to think about what's happening. What can this be equal to? If I wrote this as y is equal to root 2x plus 1, what could y be equal to? Well, y has to be at the smallest 0 and has to be a positive number. So y would be greater than or equal to 0. If I plugged in that -1/2, I get 0, and then I could plug in lots and lots of positive numbers. But I could never get a negative number because this symbol means the positive square root. Okay, we're going to do one more, e, but I also want you to state if it's a function. So I'm going to do y squared is equal to x plus 1. Well, when I look at this and I think about what's happening, is it a function? Well, it's not a function if I can find like different x's, or sorry, a single x that goes to two possible y's. Well, if x is 0, I know that y could be 1. If x is 0, y could also be -1. Because what I can do with this is I can say that x is equal to y squared minus 1 and kind of plug in a y value, two different y values, and get the same x value. So this is not a function. And in fact, if I graph that on a graphing calculator, it looks something like this, where it fails a vertical line test, something that many of you are familiar with. So just because it's not a function doesn't mean I can't answer questions about its domain and range. So I'm going to look at the domain. Domain means all possible x values. Well, if I look at this equation right here, x would have to be -1 at the smallest, but it could definitely be bigger than -1. It just can't be smaller than -1, because there's no way to plug in y values to get something smaller than -1. So Lx such that x is greater than or equal to -1, and then I have my domain. My range then is kind of looking at this from a reverse perspective. What can I plug in for y? Well, there's nothing you can't plug in for y, because you can square anything and then subtract 1 and have that be equal to another number. So my range would be all real numbers.